Okay, so good afternoon and welcome. I'm Lori Wary from the Association for Iron and Steel Technology, or AIST for short. I thank all of you for joining us today. We're happy that you're with us. So we'll be reviewing our grants with the help of the committee chair and a past recipient for each grant, and they will be introduced as we go. We hope you'll find the information helpful and get you excited about the steel industry. Feel free to ask questions at any time. We will be pausing throughout to ask for questions as well. So let's get started. AIST is a member service organization supporting the steel industry. Our mission is to advance the technical development, product production, processing, and application of iron and steel. To that end, we provide networking opportunities to meet others in the industry. AIST provides educational training conferences and webinars to share the latest steelmaking technology. And most important, we work hard to develop the next generation with the help of university faculty. The industry needs bright, talented, hardworking people. The AIST Foundation is the philanthropic arm of AIST. The mission and purpose of the foundation is to ensure that the iron and steel industry of tomorrow will have a sufficient number of qualified professionals. The foundation and steel industry offers faculty and student opportunities with and within the industry. All programs are created to introduce university faculty and students to the industry by providing access and funding. Each year, the foundation awards $750,000 in grants, scholarships, and student programs. We are able to provide these programs through the tremendous support from the industry, including companies such as Cleveland Cliffs, ATI, Ridow, Nucor, SSAB Americas, Steel Dynamics, and United States Steel Corporation. So the purpose of this session today is to increase the number of the number and quality of professional proposals submitted through our grants, and to provide guidance through the submittal process. The AIST Foundation offers 4 grants annually for a total of $195,000 to the university faculty. The grants are the Kent D. Peasley Junior Faculty Award, the Digital Transformation Steel Technologies Grant for Manufacturing in Steel Industry, Steel Curriculum Development Grant, and the Don B. Daily Safety Grant. The goals and the purpose of all of our grants is to bring industry awareness, interaction, and technology to university faculty and students, to increase the number of engineering faculty with a vested interest in the steel industry, increase the number of engineering students electing to pursue careers in the steel industry, and to connect universities with steel companies to form partnerships in new technology. All the grants are open to a professor and team of students in all technical engineering, scientific, and mathematical university departments at universities in North America. All grants require at least one mentor. It is recommended the mentor be contacted prior to preparation of the proposal, and the mentors will provide a project or issue at their plant for the grant project, guide the professor in preparation of the grant proposal, provide access to the plant for the professor and students during the project, and help professors become better informed about the steel industry. The deadline to submit proposals for all grants is the May 31st each year. The proposals are evaluated by a committee of industry professionals. The recipients are typically selected by August. A year-end report is also due on May 31st for all the grants. A request for continued funding is required for any multi-year grants at that time as well. All grant recipients are encouraged to have at least one student present their completed project during a technical session at AIST Tech. Any costs associated with the presentation should be included in the proposal. These costs may include travel and conference registration. And finally, to ensure the grants funded by the foundation go directly to the intended purpose, it's the policy of the AIST Foundation to not allow overhead costs. Now, in addition to all this information, each grant was created to reach university students in a different way and have individual requirements. So to start, I'd like to introduce Colin Keller, CMC Steel, CM Commercial Metals Company, and he's chair of the Digital Transformation Technologies Grant Committee. Colin?
All right. Thank you, Lori. And good afternoon. The Digital Transformation Technologies Grant that was established in 2017 to challenge university teams to submit proposals for grant funding in the theme area of digital technology within the steel industry. And this includes machine learning, big data, simulation, augmented reality, cloud computing, additive manufacturing, system integration, autonomous robotics, industrial Internet of Things, and cybersecurity. This grant awards $20,000 annually. The grant is to support professors and promoting the industry to students who are interested in digital technology. One mentor from the steel industry is required and must be identified in the proposal. A list of mentors is provided on our website. Proposals should include a detailed description of the work plan with project deliverables such as potential models and outputs, a schedule including a list of anticipated tasks and milestones, estimated distribution of the total project cost, includes stipend for the professors or students, and transportation costs for plant visits. Making these visits early in the year is very important. A resume or CV of the professor, including previous faculty and student interaction with the steel industry. Clarification on the proposal being either a new project, a continuation of a previous effort, or intended to be a multi-year project of up to 2 years. A letter of support from the professor's university department head and from the industry mentor. The evaluation of the criteria for these applications, first is student engagement, and this is 50%. And this is to increase the number of students studying digital transformation technologies with a strong emphasis on steel manufacturing. And here again, to provide a direct student interaction for the awareness to the steel industry, very key. The probability of success. And this is the aim of the project proposal, the methodology and the communications for clarity and completeness of the proposal. And then the industry awareness and impact, which is 15%. And it includes the widespread applicability to the steel industry and a deepening of understanding of technical issues. And then finally, the time, schedule, and milestones. What is the plan to achieve the project goals within the time frame allowed? What are the milestones? And need to ask, are there any questions regarding digital technology?
I do have questions. My name is Ephraim Massawa. I come from Southeastern Louisiana University, and thank you for your presentation, Colin.
Yes,
I just wanted to know you said the student engagement carries about 50% of the total weight of the evaluation criteria. What goes into the student engagement? Does this mean like publications? Does this mean the number of visits the student has paid to the industry? What actually means to this criteria?
Here again, it's getting the students along with the professors engaged in the project, and it's at all steps of the project with helping develop it, and then being involved in all the different steps, being engaged with the different steel industry representation, forming some type of a relationship with the group when you go out in the field. And it would be good, with doing that, that's how we get students involved in the steel industry, to build that relationship. We feel that's very important. And that's why we have such a large percentage of the evaluation based upon student engagement. So it's in all aspects.
Thank you very much. One more question is about the same thing, the evaluation criteria. So the 50% goes to the student engagement. What about the rest of the evaluation criteria? What covers what? And another question following that is the sustainability of the project. I know it's $20,000 a year. And so if you have a project that will span for 10 years, for example, is there a way that the steel AIST could fund that? And is there a way to probably use that as a criteria to evaluate the project? That there's a sustainability plan for that.
Yeah, I understand the question on the 10-year. We'll have to bring that up and talk about that later as different opportunities. I think the possibility of the 1 year or 2 years opening the door and getting you involved is, that's the put in, and that's getting involved. And then there's other opportunities to bring up and always make requests for different types of funding or a different type of a grant. The other areas, and I should have said that, I'm sorry, the probability of success is 25%. The industry awareness and impact is 15%. And then finally, the time, schedule, milestones.
That's 10%. I think
we lost him.
I think he froze.
Oh, did he freeze?
Oh, there he is.
Can you hear me?
We can now. You froze for a little bit.
Oh no. Okay.
Yeah.
Okay. Well, I was talking about the 10 years, Lori. Did you hear that?
Yeah, we heard that.
Okay. You didn't commit to anything. That's
percentages.
Good. Okay, and through our percentages. And I was just saying, are there any other questions? And then with that, I want to move on. And here again, I'd like to, it's my honor to introduce the first recipient of this award who did this in 2019, Dr. Jen Azal. And she's from Purdue University Northwest. Dr. Azal will tell us about her project and her experience. And we've visited her school and her university, and it's very impressive. Dr. Azal, thank you.
Thank you, Colleen. Thank you, Lori, to organize this. It's a great opportunity. I'm very happy to share with you for this, grants for the proposal development. And we got a good question, so that we should help answer that. Also, the project's impacts. So first of all, this is a great, exciting area. It's new. When AIST started this new grants, we're all excited, but people are wondering, $20K is not too much for faculty, right? But so when I decide to apply this, so I'm mainly looking for the impacts and also future, sustainability. So what I did was first I talked to our internal team member. I have a Center for Innovation Revitalization here, right? So all our staff are excited about this. Let's do it. This is a new area. We want to get into it. And then second thing, most important thing is talk to industry collaborators. When you start to write a proposal, you want to already have a good industry mentor and the collaborator which can guide you through, but the most important, can implement. So after that, the writing part is easy. Professor all knows how to write the proposals, right? However, for this specific grants, we focus on three things. The number one is research. because it's a new area. You do need to do a lot of research. And then second one is education and / workforce development. Just like the question will ask, what kind of students involvement? So in our team, we have a staff, faculty, as a leader, but the students are the one directly doing the development under guidance. So they are participating in the project development, and we also take them to see the plans, the process. But in addition to the project team, we invite senior students to participate, not paid by the grants, okay? And the graduate students for thesis. And also we organize events we call Steel Week, the whole week. Then, so that's important. So student involvement is multiple aspects. It's not just project itself. Then the third one is extremely important, at least to our team, is the carry on the project, sustainability and implementation. So of course we have a center, we have consortium, but when we write the proposal, we already have that in our mind. We want to carry on. We don't want to just do 1 year project. We already planned for 3 years, even 5 years. So that's the 3 components I think is important. And when we did that, write the proposal, after we finished, we got excited. As a faculty, we know if ourselves is not excited, by our proposal, the chance to win is not high. So that's for proposal development. And so, but also make sure you constantly communicate with mentor before submitting. This is what you want. It's not what you want, it's what they want. It's what the industry wants, okay? So you can have a lot of scenarios you want, but if that's not the industry want, it may not fly, okay? So then let's move on to the project side. So we got the grants. We have weekly meeting almost with our industry mentor. And that's very helpful. Again, I call this a bottom-up approach. We start with what do you need and what can be implemented. Then we build on the model, all these things. So now the good news, we have model finished. We actually did above beyond for the proposal. We added the software development. And last week, actually good news is the Steel Dynamics started, install software. So far, so good. And so that's very exciting. We had 2 graduate students. They actually finished their degree and got accepted by PhD at the West Lafayette program. Okay, 2 students and the senior design students. And so that's big impacts to the students directly involved. And industry liked it. Our consortium will carry on. Other company will start to, want to use this. And we have a lot of awareness for the students. And also, we got that's a surprise. When you do a good job, that's always a surprise, right? We received the Best Paper Award for this project. So what is the project? You can see from this slide. We basically use the machine learning as a tool. We create a software. And that software will be interacted and installed in the plant to control the casting temperature. So what's significance is that currently most places they trying to adjust the temperature manually for the ladle, then in order to control casting temperature. So very limited information. And so with our tool, actually with operator can use that based on prediction to make adjustment in the ladle part. So therefore the casting temperature can be consistently reached to desired temperature. So I'm going to stop right here. Any questions? Well, I guess I can say one more thing, Lori.
Sure.
As a professor involved in AIST since 2004, I want to share with you my experience in general with all the other professors. I've been active for other societies and mechanical engineer, and they're all wonderful, but I can tell you, AIST is certainly on the top of my list, which is the most organized, most friendly, most supportive. Okay, So if you are involved with AIST, yourself and your students will be greatly benefited for a long, long time. Okay?
Very
Thank you.
nice, Jen. Thank you. Okay, so if there's no questions for Jen, then I'd like to introduce
A
Mike
quick question.
Kirksmore.
Quick question.
Oh, go ahead.
Yeah. And it's very interesting to see this software being able to optimize the casting temperature. My question is, how high are these temperatures coming around? How many people work around the casting environment of this steel? Because I come from the occupational safety and health aspects of that, and I see the usefulness of this to determine heat stress. And it could be like we could use the simulator to create a work regimen for people in and around the casting area. And so, how many people work in the area, if you don't mind asking?
First of all, we're going to have a big presentation in digital transformation meeting in 2 weeks. Okay, you can sign up, listen to details, but the short answer is there's no limitation on temperature part. Whatever we add on the tool, currently operator is adjust the ladle temperature. Okay, if it's to predict the to control the casting temperature. So if it's too high, you have to lower down. If it's too low, you have to add up in the ladle furnace. So basically, so right in the past is manual. With this one, they can be almost automatically, but basically more accurate and less trial and error. I hope that answers your question.
It does. So this means it's inside of the casting equipment and not around the area, the casting area, right?
No, it's not an additional add-on equipment. It's actually casting. You have a casting, right? But the casting temperature is affected by the ladle. The ladle transports, liquid, right? And that normally the last stop to control casting temperature is the LFM, okay? But that temperature all affected by is a new ladle, how many runs they are doing, and so many parameters during the whole ladle process. Okay, if you're interested, I can tell you more, after this meeting, or just sign up for AIST, Nashville or Pittsburgh digital transformation. We'll have the whole description on that. Okay?
Thank you.
Thank you.
Okay. So now I'm going to introduce the chair of our Kent D. Peasley Junior Faculty Award, Mike Kirksmore. Mike?
Thank you, Lori.
Mm-hmm.
I'm going to review the Kent D. Peasley Junior Faculty Award. This award was established in 2013 in honor and memory of Kent D. Peasley for his unequaled passion for teaching and promoting the steel industry to students, faculty members, and steel industry personnel. His achievements forged a legacy of encouragement to all those dedicated to advancing the technical development, production, processing, and application of iron and steel. This award provides $35,000 per year over 3 years, and one new award is given each year. It will assist a junior faculty in building their research and professional service activities towards obtaining tenure. It's open to faculty with at least 3 years remaining to tenure. Requires 2 mentors, one currently employed with a steel producing company and one with an established professor active in AIST. And as mentioned before, available mentors are listed on the AIST website. Recipients receive reimbursement for registration fees and travel expenses for up to 2 AIST events per year, such as training courses, member chapter events, and AIS Tech. Proposals should include a 3-year plan that includes specific activities towards building connections with a steel company or supplier to the steel industry. Specific activities towards building student interest in the steel industry. Plans for a steel-related student campus event and other programs to obtain direct student contact with the steel industry. A resume with present position and years of tenure track. A estimated distribution of total cost by year. Name and contact information of the mentors. Letter of support from the university department head and letter of support for both the academic and industry mentors. Proposal will be evaluated according to the following criteria. First is student and faculty engagement. That's weighted 40%, and assist the junior faculty in building their research and professional service activities towards obtaining tenure. Increase the number of students planning a career in the steel industry by getting them involved in events, courses, and research, and to promote the steel industry to students and faculty members. Second criteria is value to the steel industry, and that's weighted 40%. And for here, looking for direct benefits through the innovation, creativity, and application of the proposed research. Provide direct student interactions with the steel industry, and increase the potential to recruit more students for employment in the steel industry. And the last item for criteria is qualifications. That's weighted 20%, and that's based on the capabilities of the professor and the team to fulfill the program objectives. Other factors considered under this criterion are project schedule, milestones, and decision points and overall costs. Are there any questions? And I wanted to answer Ephraim's question that he had before, because I come from a casting background. So when you're an operator up the caster, which might be answering your question, usually it's two operators that open that ladle for that ladle exchange. And I'll just say on average, you're probably casting at 2850, so 2,850 degrees in the tundish. That tundish is covered with either a cover or insulating material, so they're not necessarily feeling that direct heat. And a lot of the situations have operators that go into air-conditioned pulpits, so they're only out there for that ladle exchange for a short time and then remove themselves from the element. So I thought that might have been the direction of your question earlier, so I just wanted to add that before you might have or anyone else has an additional question on this topic. So.
Thank you, Mike. Yeah, that's the question. 2,800 degrees C or Fahrenheit?
Fahrenheit.
Thank you, Mike. I thought I'm not supposed to tell the details and number.
It's just an average number. It might be a little on the high side, but just to give you a flavor.
So it's basically it's control the tundish temperature,
Okay.
but you adjust the ladle, LMF.
Yeah, I'm totally with you on that. But for me, being from a casting background, I wanted to maintain that tundish temperature at exactly that right temperature so I could run maximum speed. I was looking for productivity. So very critical for what you send that ladle up to the caster.
Mike, I have one question for you.
Yes, sir.
And this question is about the specific activities that you have to build into the project. One of them is for AIST reps to visit the campus. Do we have to build that funding into that to cover for that cost?
For AIST to come, Lori, if you want to comment on that, I think that's something
maybe I could comment on that.
Okay.
Is that okay?
Yes.
So I think, Ephraim, you could build that into your budget, but my experience is that the steel industry is really eager to get on campus,
Yes.
and they'll pay their own way with respect to travel. So I think as soon as you have an event and you have a relationship with a couple contacts, you'll be surprised that people just show up.
Thank you, Paul.
Thank you.
Hi, Michael. I do have a question. I'm Montserrat Lopez from Instituto Tecnológico de Morelia in Mexico. And we are working with the AIST student chapter. And my question is, what is the role of the mentors, the industry and academic mentors for this particular grant?
So I would say part of the role for the industry mentor, from my perspective, is to help with topics that will be of interest to hopefully the employer down the road for that student. So getting topics of interest that the steel producers would like to learn more on and focus more on. So being able to have that dialogue with this professor and getting those students engaged would get those goals aligned. And then when Paul talks, he can probably focus a little bit more on the purpose of that professor mentor. And Paul's got a lot of really good background at this, is just guiding that young professor down the right path of success. You know, from what I've been involved in the last few years of being with this group is, you know, getting those students engaged. If they get a taste of stepping into a steel plant or getting engaged in a research project that really captivates their imagination, we have a pretty good hook in them to bring them into the steel industry. And so those two things together, you know, making sure that the mentor that's in industry is helping guide and give some, I'll say, goalposts to focus on the right areas, and then that professor that's a mentor to help guide that junior faculty to hit all the right highlights to keep that focus and really generate and keep that interest and build up that program that we would like focused on steel to have a better prepared workforce coming our way. I guess that's how I would capture that.
And how do you measure the engagement of the students? In how many students will be working, I don't know, in 3 years in the steel industry, or are in a student chapter, material advantage student chapter? How do you measure because I can say, you know, I'm working with the student chapter and we have developed a lot of activities, but at the final point, I mean, how do you measure that? How can you say that we will be doing all the activities with this grant?
I would say, you know, part of it is you have a baseline now, and your baseline now is no students doing anything in metallurgy or steel focused. And your goal when you put your proposal together is, you know, I want to start out year one with getting 5, and then I want to increase in year 2 and year 3. And then through the reports that you submit, we see that track record, we see that activity, and those students will trickle into industry, and we'll realize that we're achieving our goal, which is to gain that interest, and you're being successful in the program that you put together. So obviously there's just some, we'll call them, you know, KPIs that you're putting out there that you're trying to achieve, and you got that 3-year window to lay out that plan and achieve those goals, and then through those reports you're going to show us that you're hitting those metrics.
Okay, thank you. And the last one, do you consider past engagement if the teacher or professor work as I'm gonna use my example. I've been working with the AIST student chapters since the past 2 years. Will you consider that in the case of this award?
Absolutely, because I think that would predict a higher success rate in achieving the goal. So I would definitely put that in consideration, and would definitely give an advantage, I would think, just due to the success rate. As long as the proposal and all those criteria are met, it would give an advantage, I think, personally.
So I do have to include that information in the proposal.
It would help. It would be very good to include that. Yeah, I wouldn't leave that out.
Thank you so much, and nice to meet you.
Nice to meet you. Thank you. Any other questions?
I have a follow-up question on that.
Yes.
This follow-up question is in regards to qualifications. And qualifications means the qualifications of the junior faculty, as well as the qualifications of the 2 mentors, right? The faculty and the industry representative. So my question is, does this industry representative be an academic, have a graduate degree or postgraduate degree or things like that? Or how long does this industry representative will have to be in the industry to be qualified to be a mentor?
Now, I'll let Lori correct me if I'm wrong. When I think of qualifications, I think of the individual professor that's applying to qualifications, and then the team being the students that are going to help you be successful in your department. Obviously, we've already kind of cleared the path for you on a faculty member, so there's an approved list. And if you have an industry mentor, that would be approved too. So the qualification part would be selecting and discussing with an industry mentor to just have them on board, and then that letter of recommendation should be compelling for that. So that's kind of already included above in the discussion. And then obviously we've already kind of cleared the path for you on an industry or a faculty peer. So my perspective, and correct me if I'm wrong, Lori, the capability is more on you as an individual and your background for what you can bring forward, and then your university supporting you with the students that you have at your disposal to move forward, is how I would phrase that.
If I could just add to, we do like the mentors to be members of AIST so that they're involved in the steel industry.
Thank you.
So if there's no other questions, I'll like to introduce our first recipient of this award in 2013, Paul Sanders from Michigan Technological University. Dr. Sanders set this bar very high for future recipients, and we'll let him share with you his projects and experience. Dr. Sanders.
Okay, thanks, Mike. I appreciate it. As Mike said, Kent Peasley had a passion for teaching and promoting the steel industry, and this award is to continue that legacy. So I'd really stress that those are the two things, teaching and promoting the steel industry. So then there's a list of objectives on the website, and those objectives say that this award is to increase the number of young engineering professors with interest in iron and steel. And there's 4 things listed under there. They want to help get the young faculty members informed about the steel industry. They want to help build relationships. They want to help recruit students to steel. So you can see 3 out of the 4, I didn't mention the 4th one yet, have to do with future talent coming into the steel industry. The 4th one, it says seed steel research. It doesn't say fund steel research, it says seed. And the reason I'm stressing this is I think so many faculty members across North America could apply for this, but a lot of us, myself included for a bit, think that maybe we're not the ones because we're not part of a major steel research effort at one of the universities across North America that does a lot of research. So what I sort of want to stress right away that anyone can apply for this who has an interest in working with the steel industry. And I would venture to say it might even be better if you apply and your university isn't working closely with AIST because they'd like to grow their network. So please apply for this, because this is really a relationship building program, right? You have 3 years of Kent Peasley, and then I'm going to talk about the steel professor afterwards. So don't tell yourself you shouldn't apply because you're not, one of the top 5 steel researchers in the country. That's not what this program is about. There were some questions about proposal evaluation. And I would argue, it's just like when you grade a paper. Of course, you have criteria that you want, and you want to see all that in one place, but really it's the big picture, right? You want to see all that tied together in a compelling way. So don't get too focused on the percentages and all that stuff. Of course, you need that, but really just put a program together that contains all the elements in a way that's hopefully original and influential. So that's sort of my big picture stuff. I want to mention that Jen Azal was my faculty mentor when I applied the first time. And as Mike said, I think AIST does a good job in helping identify members, mentors who can help out. And I think I'd really, look at those people and see if you can identify someone who will help you in the future. And the second thing about having mentors is you should like your mentors above all other things, because that means you're going to talk to them and you're going to listen to them and you're going to have a conversation and you'll both learn. So that's what I would look for in a mentor, is someone you want to spend time with, someone you want to learn from. And I also agree with Chen that I think AIST is one of the most relationship-based professional societies. So once you get in, and maybe this is your way in, they're going to keep up with you. I mean, you can't hide from AIST, right, Lori? They'll find you, they'll track you down. Jen's nodding, you see that? And then also, I just wanted to mention that Paul Lynch was the 2018 Kent Peasley Award winner. So we have good representation in this group. Wanted to follow up on a couple of points with the questions. In terms of student involvement, I would view it as sort of like a ladder. You start out with a big number of people, hopefully in some kind of AIST related organization. And then as these students express interest, you help them learn more with the eventual goals of, getting internships in the steel industry and eventually employment. So I think what you want to see is a progression, right? From starting to finishing, and finishing might be having students working in the industry. And that's all I have about the Peasley Award. I'm also going to talk a little bit about the Steel Professor Award, but are there any questions following on what we discussed earlier?
Yes, Paul. Hi, it's Montserrat again.
Yes.
I was thinking that the mentor has to be an AIST faculty member, but I've been looking in the list that you offer in the website, and my question is, the mentor could be someone in my faculty, in my institute?
I mean, I don't think there's any rule against that, but I would encourage broadening your perspectives and getting a faculty member somewhere else. I'm sorry, Montserrat, I missed what you were saying.
Okay, sorry. Yeah, my internet was failing. So it's recommended that it should be someone on the list that you include in the website, but it's okay if maybe I choose someone in my institute.
Yeah, I don't know if there's a rule against choosing someone in your institute, but I think it would be better if you chose someone outside, because they'll help get you more perspective and more relationships again.
And you could possibly have two, one from your university and another from outside your university.
Okay, that's great.
Yeah.
Thank you.
Okay.
Actually, that's a very good point. I would like to add on. The faculty mentor, we are like colleagues, right? You like to be friends, but they are actually your advocate, because, you are the junior faculty. Like I senior faculty, our job is want to find a bright, young junior faculty and see them grow, help them. So that's first point. Second point, like in the United States, National Science Foundation has this career award. So this junior faculty award, it was like a mini version of the career award. Because I was in the foundation that time, we don't have that much money, but this is a great idea. So what I mean, this is not just research proposal. Make sure, as Paul said, there's education components. And since you are also the advisor for the chapter, and integrate that activity together. So it's like how this will help you for your career, how this will make impact to students in your program, and that has long sustainability. And we want to see you like Paul, continue grow, become a leader. So I think that's the idea.
Yeah, and building a little bit on what Jen said and what Lori said earlier, since AIST gives this as a gift, it's not overheaded. The $35,000 a year goes a lot further than an NSF grant, where you lose, at least if you do that in the US, you lose about half of it to overhead before you even get to touch it, right? So it isn't as big as a career award, but it is a little bit bigger than it appears. And the last thing I want to say about that, since it's a gift, it's discretionary, right? And I think AIST does a good job of trusting us professors to invest wisely. And then the way they check this is every year they ask you what you did, right? And you sort of tell them, I spent this much on this, spent this much on this. And then they look at that plus the metrics that you provide in terms of your impact. And that's how they evaluate the value from what you did. And I guess this is a good time for me to transition to the Steel Professorship. And what that is AIST was finishing up, in my case with me as a Kent Peasley Award, and they wondered, well, what's next? And to their credit, they thought, well, we should continue our relationship, because if you start with junior faculty members, right, they're going to have a long career. So they came up with this, and I think it's a good idea. And what it is it's about $5,000 a year. It's very similar to the Peasley Award and with the objectives. And they want a little report each year, but it's not onerous. So I think my attitude towards the Steele Professor Award is I'm trying to do new, big, impactful things. And the reason I want to do that is because everything's changing, right? The students change every year. The economy changes, the industry changes, and we have to keep changing. One of the things I did when I started with my Peasley Award was do a Steel Industry Day. And I think almost all the winners so far have done that. And what's happened on my campuses is all the other industries are doing it now too. So we've sort of saturated that. So we're trying to come up with new ideas. And I use the money from AIST as seed money, just like the proposal says. And it's strange. Sometimes if you have a good idea, you don't even end up having to pay for it. Like I've been telling AIST for a couple of years that I'm going to set up a steel wire arc additive manufacturing cell. And I mean, they're only giving me $5,000, right? And these cost like $100. But between a donation and some used equipment, and then somebody else jumped in and paid, I didn't end up spending any money. I put the money back in the AIST bank, and I came up with another idea. So now I'm trying to recruit more undergrads from high school and from the undeclared major in engineering. And so I've got a couple plans that will invariably involve steel in the steel industry. So that's what I'm going to put in my report this year. So I think it's really flexible. They trust you, and your track record sort of tells them, you know, what to expect going forward. So any questions about Steele Professor or Kent Peasley before we move on?
I just also want to add that this is your 5th year of being a Steele Professor. So now we're at the same point as what do we do now? So I'm sure the foundation will be working on that.
Yeah. And, you know, I look forward to having some interactions with Lori and some of the foundation too, to try to provide some feedback on, you know, at least my vision at my university, right? And I think other professors do the same from their vantage point.
I'll put you on the agenda.
Okay.
I want to add my comments about Paul. He certainly set up a high bar and served as role model. So, you know, you follow his footsteps, you'll be successful. Paul, congratulations.
Yeah, thanks, Jen. Well, you never know what's going to happen, right? Because this is new. Like Lori said to me one day, you know, we should really gather the awardees together. We should have like a lunch. We should have a discussion, right? And it's been a little messed up in the pandemic, to be honest. But we're hoping. I'm even trying to figure out if there's time to do that in Nashville this year with who's going to be there.
Maybe we can. I'll be there.
So there's, you know, little opportunities pop up as you go along.
For the potential applicants, feel free contact me. You know, if you need me be the mentor. I know Paul's is easy one for me. You know, I just say good job. You know? Great.
Yeah, but like Jen says, you know, it's sort of like us mentoring our students, right? We want to mentor our colleagues too, to help them get involved in this industry if that's what they want to do.
So Paul, I have a question, follow up on the Steele Professorship.
Yeah.
This Steele Professorship, it doesn't have like an outline on how to write that grant. Is this like awarded to a past recipient of any of the grants?
Right. Yes, you're correct. It is a follow-on program for the Peasley. And I don't know how the committee does it actually at the foundation, but I think they probably already sort of have a sense about the winners of the Peasley Award. And then, you know, after the first year of the Steele Professor, I think they probably evaluate, you know, that continued progress. So there's no specific proposal, actually. They're just as a report at the end of each year. And Lori will remind us.
There is an application that you can't remember, it's been 5 years. But there is an application that, in their last year of the Peasley Award, they fill out, and the foundation trustees approve them to the next level. So,
But it's nothing like the initial proposal. It's really short.
It's just restricted to past recipients of the Peasley Award.
So the Peasley Steel Professorship doesn't have a start date or end date, correct?
It sort of does. It's by academic year, I think. You know, like when Paul Lynch was awarded in 2018, I think his first year then was 2018-19, right, Paul? He's nodding there. So I think it's an annual thing.
Yes.
And then you put in a report at the end of the academic year, and the foundation reviews it in the summer.
So for each academic year, how many steel professorships can you have? Or for each academic year, how many steel professorships?
Yeah, normally there's 3, because it's a 3-year award and they're cycling through. What are you saying? There's 5 steel.
Are you meaning for the Kent Peasley or for the steel professor?
For the steel professor.
Oh, okay, yeah.
They can get that for up to 5 years.
Okay. Thank you.
Okay, if there's not any more questions, I think Mark Olson is up for the Steel Curriculum Development Grant.
Great, thank you, Paul. I know we're running a little long, so I'll try to move this along a bit. So this grant was established in 2005, really with the goal to increase the number of students studying a steel-related curriculum. It's a 3-year grant of $25,000 payable over 3 years. Typically, that's $10,000 in the first 2 years and $5,000 in the 3rd year. The objective is to support a project that will enhance steel-related curriculum. It's to assist, in order to assist the applicants in forging steel industry networks, and I know we've had quite a bit of discussion on this, mentors are required for this grant. And as we talked about, AIST will assist in identifying a mentor as needed. So your proposals should include, 1, a schedule for the project, including a list of anticipated tasks and milestones. And then we'd like to see a detailed plan of your project, an estimated distribution of total cost by year, past involvement with a steel plant. We think it's important that you're engaged with a steel manufacturing facility. And we propose, the proposal should include direct student involvement with a steel plant. So it's pretty important as we review these proposals that we see that engagement between academia and the steel manufacturers. So when we go into evaluation criteria, we have 4 criteria that we evaluate the proposals. The first, weighted at 30%, is the benefits to steel-related engineering programs in North America. The goal is to increase the number of students studying steel-related engineering programs in North America. We want to engage students from different disciplines in steel-related engineering studies and to provide direct student interaction for awareness of the steel industry. So what we're trying to do is really get the students engaged in the industry and interested to, as Paul said, learn more. The second criteria is academic impact in North America. It's weighted at 35%, and that's the potential of the project outcomes to enhance or update steel-related curriculum in North American universities. The third criteria is value to the steel industry. It's weighted at 20%. In the fit of the proposed curriculum to the theme of the engineering majors at North American universities, and that's metallurgical engineering, material science, chemical, electrical, mechanical, industrial, environmental, and computer science. The potential of increasing the number of students employable by the steel industry. That's really what we're looking for. And then the last criteria is qualifications, weighted at 15%. And that's where we talked on the previous grant, where we look at the expertise and capabilities of the team, what the team brings to the project, and hopefully we get a good sense that there will be a meaningful on-time completion of the project. But we also, in that qualifications, look at other factors like project schedule, milestones, decision points, and overall cost. In addition, the overall quality of communications, the clarity of your proposal, and completeness of the proposal is also considered in the qualifications section of the criteria. So that's I went through that pretty quickly. Please, if there's any questions, we will try to answer those for you before I turn it over to Professor Lynch. Okay, well, with that, I would like to introduce Paul Lynch from Penn State University. Dr. Lynch is a recipient of both the Steel Curriculum Development Grant and the Kent D. Peasley Junior Faculty Award. So he's been, well versed in the process, and certainly that's why we asked him to communicate, his thoughts on submitting proposals for these grants. So, Dr. Lynch.
Mark, thank you very much. And I just want to, again, just thank everybody in AIST. It's been a tremendous support, and it's really helped me, tremendously as a junior faculty. Speaking on behalf of the curriculum development program and that specific grant, I had just got here to Penn State, Behrend in Erie, Pennsylvania, and I was really looking at, in our department, I'm in industrial and manufacturing engineering, what was in, I teach our manufacturing processes course. And, the first thing I was looking at was our program in industrial manufacturing engineering. But at the same time, in our entire School of Engineering, there's really, we have a broad range of engineering programs, namely the ones that feed our Material Advantage AIST program, or industrial, mechanical engineering technology. And we also have a Master of Manufacturing Management program. So really, when I first started looking at this, again, I started within my department, but really wanted to kind of work with my colleagues across those areas, those specific areas, in terms of trying to see, first of all, benchmark what was actually being taught in steel. And that's the very first thing that we did. We looked in our program, industrial manufacturing, mechanical engineering technology, and also in our Master of Manufacturing Management program, because a lot of those students coming through that program are actually working in the area in the steel industry. So first thing was kind of benchmarking what was happening in our department and also in those other departments. And then really the two main things that I hit on in terms of curriculum was just making sure that in those areas that we were hitting the basics, of the basic materials, it just starting with basics, the carbon content, looking at the effects on hardness and tensile testing and impact behavior, and trying to standardize some materials in our labs across not only my department, but also willingness to share them in other departments. And then after the basics of steel, we started to look at, we have pretty nice manufacturing facilities, looking at the manufacturing processes of steel. So looking at, rolling processes, forging, casting, and welding. And we really centered around those two areas. And one thing that Paul Sanders had said, he used the word seed a bunch of times, and that's really one thing that's really been successful in our efforts. Yes, we've developed curriculum here and there, and we've made sure that there's steel in all of those areas in the programs. But one thing that we've done, I think, effectively with that $20,000 or $25,000 is that working with the university, at the same time, we were able to build up a really nice metallography lab. They bought a brand new polisher. It was probably $50,000 or $60,000 polisher. We had, right before I came here, we got a brand new ESEM. Right now, they're buying a new state-of-the-art hardness tester with a bunch of capabilities that they're bringing in. They bought in the middle of this curriculum grant, the school bought a benchtop rolling machine that we never had before. And also, we worked with Lincoln Electric and got new welders for our welding labs. So we kind of leveraged the support AIST gave us, and also work with the school to really put all of this together. And now we have a really nice metallurgical lab, and we really add it to our manufacturing labs. So what did the resources for the grant, it was really spent on funding students to help with some of this development, help in the labs. We bought measurement equipment across the disciplines I mentioned, calipers, micrometers, surface magnifiers. We bought some standard materials that everyone can use in their labs. We also had some testing done at labs to have some nice standard set of properties and samples as well. We bought polishing supplies. We bought, desiccators for our samples as well. Those are some of the things that, again, the resources were used for. And really, when I look at it, the outcomes, it's been really beneficial. The first thing was I wanted to make sure that there was steel in the School of Engineering being taught, and we made sure that. I know it's being taught in our program, mechanical engineering technology, and also in our Master of Manufacturing Management program. We've built up our capabilities, as I said, metallography, testing, rolling, and our welding capabilities as well. And then the big part of it was getting students to help put together the activities and look at getting students involved in the industry. And that's really spurred one of the things they talked about with mentors. The mentors in industry, we've gotten those folks that we've worked with. Actually, Kareem was on here earlier. The folks there, the folks out at, Cleveland Cliffs, Rashad and his folks, we've really developed some really nice relationships. And we're seeing students going to work in those areas as well and come back and give back. And also working with Paul Sanders and Laura Bartlett. Very closely, and I've gotten to know those folks very well, and they've helped me. So it's worked out very well. Hopefully I gave a nice overview of what we kind of did in the program, but those mentors and those relationships with those companies and professors have really been beneficial.
Very good. Any questions for Dr. Lynch?
Hi, I do have a question.
Okay.
What are the main difference between Steel Curriculum Development Grant and the King Peasley Junior? Because I think that it's kind of the same, looking for connection between the students and the industry. Of course, the grant, but what are the difference? I mean, a young teacher can apply to this award too, to this grant?
Yes. You can certainly apply to both grants. The difference is more the curriculum is what you're teaching the students. So updated web information, books, it's not anything for them to learn.
I think the main goal of the curriculum development is to develop curriculum that it engages students, in perpetuity, right? So it's actually changing curriculum that will be able to be useful for years down the road and continue to engaging students. So more curriculum based than the Kent D. Peasley Award.
Thank
Hopefully
you.
I answered that question.
Yes, thank you.
You're welcome.
So I have a quick question. So in the curriculum development, based on what Paul just presented, it seems like you can have small items. For example, if you have, let's say, materials deformation, you could bring a little bit of a piece that students could learn about materials deformation, and then jump on to another thing that will probably address material hardness, or jump to another thing that will address maybe welding of steels, or maybe how do you prevent yourself from welding fumes, for example. If someone is welding and you need some local exhaust ventilation system around them, would that be considered like curriculum development?
From my perspective, I think the number one thing was making sure that, the students were being somewhere. Students are being somewhere, they're getting subject to steel curriculum to begin with. All right. And we did it in two levels. One was really the basics and properties and how all that fits together. And then the second part was manufacturing. So I think number one is making sure that our students in our universities are getting subject to some steel curriculum. I personally believe that's number one. And then in terms of maybe, what we have in our resources here, in our labs, things like that might be different than somewhere else. So in terms of how deep or what is all covered, that could differ, I think, by school. But we kind of had to play on our strengths and what was available in our labs and what our administration could bring in terms of how we're actually engaging the students with the steel curriculum. But I think the answer is there's probably a lot of different pieces, right, that you could teach, but we had to play off of our strengths, kind of here and also in the industry around us. but again, the number one thing I think is making sure that their students are seeing steel, right, in their curriculum.
Yes.
I think I like that the important thing is also the steel industry awareness. In your curriculum, you need to build up that, maybe take a student to field trip, see the plant, interact with steel manufacturer, the plant people directly.
Yep, that's a
That
very
will
good
be
point
fun.
too. And we try to do that every single year. Obviously, this year with COVID, we were restricted, but we did that every year. And we one of them was ENF in Irvine. We did McInnes Rolled Rings. We did last year. We try to do that every year. And then also went obviously now it's Cleveland Cliffs in Cleveland, but we took students there as well. But yes, that's important as well.
Okay. We are really running over. I apologize for not allowing enough time for everybody, but I think we better move on to Kristen Malash, who is our chair of our Don B. Daly Safety Grant. Kristen?
All right, thanks, Lori. So in the interest of one being last over time, safety is usually first, right? On the agenda.
I'm sorry,
So,
yes.
No, it's okay. I'm not used to being last and I'm not used to being succinct, but I will try for today. So this grant, I think, I don't know, I'm not seeing your slide move, Lori. If you want
I'm sorry.
No, it's okay.
There you go.
So the grant was established in 2011. It is a $10,000 grant, and it's for 1 year. And this grant, it's in partnership with the Steel Manufacturers Association. And it's to commemorate the life and industry service of Don B. Daly, who was a compassionate man who truly cared about the safety of all employees working in the steel industry specifically. So the objectives are really, you can imagine, right, just from the name, it's to promote a safe workplace for the steel manufacturing industry, increase the number of students who study health and safety awareness relative to, a heavy manufacturing environment. It challenges the university teams for funding in the theme area that they select. And then similar to the other proposals, just talking through the plan and the schedule to meet the project, what your budget would be. We definitely look also for that steel plant interaction. So something that's applicable to the steel industry, and just some examples of potential topics that have been or are in the list that have been included would be safety management, railroads, mobile equipment, different types of machinery, electrical apparatus, falls, hazards, confined space, industrial hygiene, PPE, communications technology, technologies and things like virtual training, things like that. We've seen those types of proposals. And I think in the interest of time, I'm just going to pass it over to Dr. Sathi, if that's okay, Lori, and let him speak about, he's the 2020 recipient of the grant, and let you kind of talk a little bit more about it.
Thank you. Thank you, Christine. Thank you, Lori. So, in the interest of time, I'll try to make it quick too. So we are from Central Washington University. So if you're not sure where it is, it's in Ellensburg, Washington. We are 100 miles east of Seattle. So we are on the West Coast. So the main purpose when we submitted this grant is the words creating awareness was the biggest key. So I'm in a department I'm a chair of a department. I have 7-degree programs. We have construction management. We have a classic Bachelor's of Science degree in occupational safety and health. So we have graduated around 40 students who graduate and enter the safety industry as a professional. We have a mechanical engineering tech, which has 2 branches, like specialization, a manufacturing side and a design side. So we have a casting lab, we have a welding lab, we have metallurgy lab. So our idea was we didn't have our students did not have any particular focus on the steel industry manufacturing side. 80-90% of my students were entering the construction industry, very little, if not pretty much zero, entering the steel industry side. So we want to create awareness to our students. We wanted to start it by introducing some case studies focused on steel manufacturing process in our manufacturing safety and health class, because we didn't we typically cover the OSHA regulations and so forth. We wanted to bring in a real life scenario. So that's why we proposed this grant. Unfortunately, we got it. Very helpful, ASC, Lorian, very helpful for that. I'd like to thank the committee for helping us find a mentor. So we had Dave Reinhardt from Commercial Metal Company as our mentor. We had Nucor Steel was our on-field interactions, industry interaction. Oliver Lyles from Nucor Steel. We were able to tour. So from a benefit standpoint, from a student's benefit standpoint, students were able to tour a plant and able to see the entire manufacturing process life cycle for rebar manufacturing. From a faculty standpoint, I come from construction and my colleague has some background. We were able to see the entire process. So we were able to teach students in an informed fashion. And with collaboration with our mentors, we created 7 case studies. So instead of using PowerPoint, like death by PowerPoint in a classroom, we were able to create case studies created by the students. Because we visited the plant, we observed all the processes. We picked 7 processes from scrap, sorting, or casting process. And we created a case study where the students in the classes, taking those classes, whether it's a manufacturing class or the safety class, they'll be given a scenario and they'll be asked to identify the hazard and come up with control measures. So this kind of interaction creates awareness about the industry, meets the intent of the grant, and students are very excited about another career prospect, because predominantly, because we have a construction management program, students are thinking construction is the only route to go to be in the safety profession, or even the manufacturing side. Students are exploring going to work in local foundries and manufacturing area. So it was very exciting. So faculty learned a lot, students learned a lot. Another last highlight is students were able to publish in the magazine. So they were very excited. So they were able to start on their own with guidance from faculty on how to write a paper and how to peer review, edit. And they also did the pilot testing in a manufacturing safety class. They ran the case study. So they also got an experience on how to be a teacher. So it was a well-rounded experience, and I think it was very beneficial. I would highly recommend others to apply to the grant and benefit from it. So sorry, I went really fast in light of time. So thank you.
So do we have any questions for either Christy or Sathi? And again, if you want to connect with them, just contact me and I'll work with you through them.
Quick question. Christine, could you give examples of virtual trainings that you said probably could be part of this?
Oh, I just mentioned I'm relatively new to reviewing the proposals, but one of them in the past has been like virtual reality training. So I know we've talked through, some of, if you think about, our types of training that we typically do in the steel industry, are computer-based or classroom-led. And really, there were some awesome ideas around, using virtual reality, right, to even think about more of particularly safety training, because sometimes having people, in those situations where they have to react or recognize hazards that are going around them, we don't want them to really be in those situations. But if it's a virtual reality setting, that could provide some real benefit. So Lori, I don't know if you have any other, I just remember that was a really good proposal that we'd had in maybe a few years past.
Yeah, I don't have anything to add to that.
Okay.
Thank you.
Okay. So if there's no further questions, this concludes our presentation. Thank you to the chairs and past recipients for their time and their wonderful insight on our grants. And thank you to everyone else for joining us. If you have any questions, feel free to contact me. I'm happy to connect you to somebody or help you if I can. So stay safe and have a great day.
Thanks, everyone.
Thank you, Lori.
Thank you, Laurie.
Bye.
Thanks.
Appreciate it. Bye-bye.
Bye.
Thank you. Bye-bye.